page 90. Okay, so page 90 is where you want. So the first part of page of lesson 4 was all of our identical objects. It was our repeats questions. This is an identical objects question. It's just in disguise. It's incognito. So it says Paul and Catherine are considering the following problem. Find the number of routes from A to B if you must always be moving closer to B. Okay? So one of the routes is highlighted here in bold, right? So they went here, 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 here. Okay? Well, let's try to draw out all of them. So this is another way, right? Just go east and go south. You could go like steps, like that. You could go 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 like that. Oh, I've got that one already. You could go like that. Now you always have to be moving closer to B. Okay, so you're not allowed to go backtrack. There's got to be 3 more that I'm not seeing. There's that one. No, that's that one over here. Oh no, that's not that one. Okay. What's another one? Oh, yes. That's one. Yep. Okay, there's got to be one more. So 2 over, 1 down, 2 over. Okay. 1 over, 1 over. That's this one, and then that's this one. I feel like there's one more, and then there's this one. That was one I just did. Okay, I'm missing one. Okay, there's 10. Yeah. Yeah, I just can't see it, but there is 10. Okay? So, if the question was, how many ways could Paul and Catherine get from point A to point B? Do you want to draw them all out? Technically you can, but you're probably going to miss a couple. Case in point. Okay? You want to have another way of doing this. So, there's 2 ways I'm going to show you. First way is super boring. Second way is super fun. Okay? When the teacher says it's fun. Okay? So, what we're going to do is we're going to solve it as an identical objects question. So, think of this question as going, so they're here, they need to get to here. So think of it as 3 movements to the right and 2 movements down. So you could go right, 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 down, down. You could go right, right, down, right, down. You could go right, down, right, down, right. You could go, right, there's all those different ways. So think of this as an identical objects. You've got 3 R's and 2 D's. And you need to write them in like how many orders are possible. So think of it as identical objects. So for identical objects, you do the total on the top and each repeat on the bottom. So we've got 5 movements in total, 3 R's and 2 D's. And then you've got 3 R's and you've got 2 D's. And if you punch that into the calculator, brackets and all, you'll get out 10. So the repeats questions we did were like Vancouver, mathematical, right? We did the repeated letters. We also did the mini boxes of cereal, right? You've got 3 Raisin Bran, 2 Cornflake, 4 Cocoa Puffs, right? Identical objects. This is another identical objects question. It's just in disguise, right? So that's one way to do the question. There is another way more fun way and I call it counting corners. Okay? So, what you do, they've got it started. I'm just going to just do it on a blank page here just so I can show you big. So what they did is they took this diagram and they turned it on its side to make it a diamond. I'm going to leave it flat. Okay? What you want to do is at point A, put the number 1. Okay? Physically think of these as streets. So in other words, this is a street corner, right? How many ways are there to get from this corner to this corner? Well, it's one way. How many ways are there to get to this corner? Well, there's only one way. You have to walk down this road. How many ways to get to this corner? There's only one way. You got to walk all the way down. You've got to go right, 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 or east, east, east. How many ways are there to get to this corner? Well, there's only one way. It's to go straight south. How many ways to get to this corner? One way. You go straight south. Okay, I'm going to do this in Magic Pen so you can see what I'm doing. How many ways are there to get to this corner? Well, you could go this way, or you could go this way. So there's 2 ways to get to that corner. Yes? Okay. The way this works is what you want to do is you want to go take these 2 numbers and add them. So 1 plus 1 is 2. So how many ways do you think there are to get to this corner? 3. 1 plus 2 is 3. And if we were to map it out, watch. So here's one way to get to that corner. Here's another way to get to that corner. Here's the third way to get to that corner. But instead of trying to draw them out, just add up your corner numbers. So, how many ways are there to get to this corner? 3. How many ways are there to get to this corner? 6. 3 plus 3. How many ways are there to get to this corner? 3 and 1 is 4. How many ways are there to get to this corner? Looky there. Counting corners. Way more fun. Now, what if you accidentally write 2 here instead of 3? What's going to happen? House of cards, right? It's just going to come crashing down. And you won't have a clue if you're doing it right or wrong. So these are going to be numeric response questions, where you just have to hope that you've counted right. So for our basic shapes, basic rectangles. So you should have little alarm bells going off in your brain, right? Going, what does she mean by basic? Where is this going? Okay, you'll see. For basic rectangles, honestly, this way works the best because you're just punching into your calculator. Okay? But some kids absolutely hate that method. They would much rather count corners. Okay? And risk it. Are all of your shapes going to be basic? No. So here's the deal. This method works on every single shape, whether it's basic or not. This method only works on the basic shapes. Okay? So what we're going to do here is we're just going to do a few examples together. Basic ones and not so basic ones. Okay? Okay. So, right here, example number 3. Okay? Now, the key with this, so in 30-2, the rule is you always have to be moving closer to your target. Okay? We never allow you to backtrack, and we don't put any obstacles in your way. Okay, so in 30-1, we'll put in one-way streets. So in 30-1, you can only go this way down this street, but you could go this way on this street, but that's away from your target, so that street doesn't count. So we add in these restrictions along the way. Or we'll say, uh-oh, you've blown a water main. All these street corners are underwater, so you can't go down that way. So we put blockages in your way. In 30-2, just get yourself from point A to point B, literally. Okay? So, option number 1. is to do the question using repeats. So we'll do this way first. So what you do is you do each shape. So we're going to go from here to here. So we've got 3 movements right and 4 movements down. So we've got 3 R's and 4 D's. So we've got 7 objects repeated of 3 factorial, 4 factorial. Okay? So the reason why we're doing it this way is permutations are order. So one order is right, 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 down, 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 down. Another one could be right, right, down, down, right, down, down. Another one could be right, down, right, down, right, down, down. We're doing different orders of the R's and the D's. That's why this is a permutation. I just have to divide by the repeats because I have identical objects. Okay? For the other shape has 2 R's and 2 D's. So I have 4 movements in total, 2 rights, 2 downs. Okay, so listen to my words. You're trying to get from the bus station to the concert hall. So do you have to go from here to here or here to here? Or do you have to go from here to here and here to here? And. So you are going to multiply. So you punch this into your calculator, get out an answer. Punch this into your calculator, get out an answer. And that's the total number of routes there are from point A to point B. Now, the answer can be fairly large, right? Just remember that little rectangle had only 6 movements, and it was a big 10 ways. This has a lot more different ways to get from A to B. Okay? I don't know what the answer is. I didn't bring my workbook up here, but okay. The hardest part of this is recognizing that it's a repeats formula. But essentially, look, are you confusing a pathways question with any of the ones that we've done so far? This doesn't look like anything else. This doesn't look like numbers on a locker. It doesn't look like how many 5-digit numbers. It doesn't look like spell oranges where the N has to come first. It doesn't look like anything like that. So it really does stand alone. What'd you get? Yep, that's about right. Yep. Yeah, it's a big number. No, but but look how little that is, right? But if you think about it, I would say I'm 6 blocks or 7 blocks from bus depot to concert hall. To say there's 210 ways to cover 7 blocks, that kind of makes you go, ooh, really? Yes, there are. Okay, so let's do this by counting corners. So do you have this as a blank one? Yeah, you do. Okay, so start off with your ones. So the first edge of your first shape is where all your ones go. Okay, so just do that as your first step. Okay, so now to this corner right here, you're going to go 1 plus 1 is 2. Now, it doesn't matter how you proceed. Some kids like to go horizontally. Some kids like to go vertically. If I go horizontally, 1 plus 2 is 3. 1 plus 3 is 4. This one, 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So remember that first diagram there, that was our first question, right? 10 ways to get from point A to point B. Okay, so we're going to keep going. 1 plus 3 is 4. 4 plus 6 is 10. 10 and 10 is 20. 1 and 4 is 5. 5 and 10 is 15. 15 and 20 is 35. Now, here you have 2 options. I'm going to show you both. Option 1 is to now take this 35 and carry it over and carry it down, just like we did with the ones. And now you start up again. So we go 35 plus 35, 70 and 35, 35 and 70, 105 and 105 is 210. Now again, you don't need me to tell you all the ways you could screw that up, right? Like 2 plus 3 is 5, not 6, right? Okay, so that's option 1. It works because we got out the same answers doing the repeats. Option number 2, once you get to this corner right here, just off to the side, write 35. Okay, and then what we do is start off with a brand new shape. So start back at 1. So go 1, 1, 1. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 2 is 3. 3 plus 3 is 6. So remember, we have to go from here to here and from here to here. 210. So it's your tolerance for big numbers that will determine if you carry the 35 or if you start again with the 1. It's entirely up to you. Okay? But you have choice. Whether or not you do this by identical objects or counting corners, it's up to you. I like counting corners. Just, I guess I feel like I have more control over the situation, but that's because I trust my brain. So I trust my brain over my calculator any day of the week. So, okay. Okay, so what happens if we look at this one? Okay, so you cannot do this one using permutations. Okay, you can open it up, it's fine. Okay. So here's why. Okay. Do you see a rectangle? Yes. Okay. What's left over? Is it a rectangle? No. So if you're like, yeah, but hold on, what if I just drew it another way? So if you drew it this way, here's your other rectangle. They've got this as overlap. That's a problem. If you're like, yeah, but hold on. Sure, what if you draw it like this? Draw this rectangle, and then draw this rectangle. Problem solved. No, because this side is counted twice. So when you can't make your shape into distinct shapes, here's what I mean. This shape was distinct from that shape. They did not overlap. When you have that as your picture, feel free to do identical objects. But if you have overlapping space, which is what this one is, you cannot use the formula. This one can only be done with counting corners. Because it's not just, if it was this shape here, if it was this shape here, and this did not exist, and this did not exist, and it was just this shape here, have at her. You've got distinguishable rectangles or squares. But when you've got overlapping space, that's a problem. So if on your diploma, they give you an overlapping space, you have to do it by counting corners. Have to. So I've made mine a little bit bigger just so that I can draw it a little bit easier. Now, here's the other thing. So I put the train station here and the football stadium here. If the question said, how many ways are there to go from the football stadium to the train station? Do you understand that to go from the train to the football is the same as going from the football to the train? Yes. So it doesn't matter if you start with your 1, 1, 1, 1, 1, 1, 1 and go that way, or 1, 1, 1, 1, 1, 1, 1 and go that way. You're going to get out the same answer. I always work from top to bottom. I never work from bottom to top. I just don't. But could you? Yes. Okay. Okay. So start with your ones and just follow the straight line. Don't take any bends. Just follow the straight line and stick your ones on. That is always step one. So I didn't continue the ones here because I would have had to have bent. So if you have to bend, don't put your ones in. Start adding. Okay. So 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. Okay. So here you're at 4. What this 4 means, it means that there's 4 ways to get from this point to this point. That's what that 4 means. The reason why I added 1 and 3 is because those are the corners that are coming into this corner. I'll say it again. Those are the streets that are coming into that corner. Which street is coming into this corner? Just 4. Whoop. So this is just the 4. There's nothing to add to it. Now you keep going. 1 plus 2 is 3. 3 plus 3 is 6. By the way, 3 and 3 is 6, not 9. It's the number one time that I see it. Okay. 6 and 4 is 10. 10 and 4 is 14. Keep going. 1 and 3, 10, 20, 34, 5, 15, 35, 69. Okay. Now, once you get onto the last row, this corner right here, which streets are coming into this corner? Just the 15. So we have 30, 50, 50 and 69, 119 ways to walk from the train station to the football stadium. So this is one of those trust the process. Okay. They will probably make it a numeric response, not a multiple choice, because with multiple choice, you can tell if you're doing it right or not. Whereas numeric response, you just got to hope that you got the right 3 numbers. Okay. But in terms of the hard stuff, like, okay, just take a trip down memory lane. In February, we were solving rational equations involving factoring in the quadratic formula. That is standard of excellence on the diploma. This is standard of excellence on the diploma because you can't step right into 2 identical shapes or 2 individual shapes. They're both considered standard of excellence. Depending on the unit you're in, depends on how hard the concepts get. So I would say hope for one of these on the diploma because it should be a quick, easy mark for you. Okay, I'm done. That's it.